Alright, so what we're going to do today is to take a look at the bending stress and strain distribution in a beam. So what we have in the testing machine is our beam. That's the silver part in the middle.
Point out.
Yeah. And then you see our gauges are over there on that one side. There are 3 gauges on the side that faces us, and there are 2 gauges, one on the top and one on the bottom. And then there are some more gauges. I think 4 more gauges are on the reverse side of this beam that we can't see. Now the gauge locations are given in the lab handout. Okay, and so the way this loading situation works is we have the big compression plate up on top, transfers to an I-beam, and the load splits off into 2 positions at 2 points on the beam. Right there and over there. It's kind of hidden behind the column of the testing machine, and then it's supported by 2 more supports on the outside edges of that beam. Okay, and so the load gets transferred from the top to the bottom, and it gets measured by the load cell, which is that black pancake-shaped object up on the top of the testing machine. So what we're going to do today then is we're going to load the beam up at levels of 200-pound increments until we get to 1,000 pounds. Total force. That means 500 pounds on each application point on our top of our beam. Okay, and then we'll record those strains at those different levels, and then we'll have you answer some questions and do some calculations with it. So the other thing that we have is over on this other side we have P3 strain indicators, and those will measure our strain. The units of strain are micro strain that will be in the table. And for your reference, this is a 6061 T6 aluminum beam, and you can look up the modulus of elasticity of that in our textbook. So I have one camera trained on the computer for the testing machine, and one camera will just leave focused here on the beam. And then what we'll do is I'll come over here and I'll push the down arrow, and pause it at 200 pounds of compressive force, and then we'll take a reading. Now, before we put any load on it, we're going to take an initial 0 reading, and Alan will do that. Alan, if you won't mind, I'm just writing down all the zeros. So we'll take a 0 reading before and after we do all of our testing.
Just record them here vertically. So for 0 pounds, this is our 0 reading.
We went through and we balanced these. These are P3 strain indicators. The readings that you'll see are in microstrain. You see the little mu-E symbol. And these are set up for what's known as a quarter bridge circuit setup, strain gauge circuit setup, which is wired by here. And this represents the strain gauge. And then you have 3 lead wires. The red wire is the power wire, and then the signal, and then the resistance wire. We're using 120 ohm strain gauges, and so that's why it's hooked up in this order: P plus, S minus, and D120 for each of these 9 gauges that we have. We have 9 gauges, so we're using 3 different strain gauge boxes. So we got the 0 readings. So what we're going to do then is we're going to load this up to 200 pounds. We're going to load the testing machine manually. We'll wait for a stabilized value. That's right about 200 pounds there.
Okay.
All right. Then we'll go to 400 pounds. Okay. As it's loaded, you'll start to see the beam deflecting. 600's next. Okay. So this looks like it's about 603. Okay. 800's next. Let it stabilize. It's relaxing a little bit. Okay, that's 805, so let's call it 800. Okay, all right, and then we'll go for 1,000. So that's about 1,015. So that's we're not going to mess with success. Okay. And what we'll do next is we'll unload the beam, and you'll see this pop back up, and we'll take another 0 reading. And then what you'll do for the lab is you'll take a net 0, take an average 0, then you take a net strain readings for each of these readings. So here we're going to unload it. Watch it spring back. All right, and then we'll take a net 0, take a final 0.